Mr. Hassan's Maths channel. I'm now answering question number 3 from the October 2024 Pure Mathematics P3 International A-Level Edexcel exam. And here we have a question. They told us about figure 2 here, which shows a sketch of the curve with the equation y equals f of x, where f of x is equal to 2x squared minus 10x, and x is an element of real numbers. So it's a quadratic curve, and the domain is completely unrestricted. And it says here, solve the equation f, and then it has the modulus of x is equal to 48, where the modulus of x is inside the bracket. Okay, so this is a type of question which is dealing, normally comes with transformations, but here it's with solving the equation. Okay, so how does this work? Well, basically what it means is, whenever you have f, for example, if I say f2 equals, it means I take the x and replace it with a 2. It says fy equals, I take the x and replace it with a y. Okay, so whatever is in the bracket takes the place of the x. So in this case, what this means is 2 times the modulus of x squared minus 10 times the modulus of x. That's what it means. And what we need to do is we need to solve the equation where this is equal to 48. Okay, so first of all, I'm just going to show you how this would be graphed. How would you graph something like this? And that will help us to understand how the answer comes. So when you have some change taking place inside the function, like when we do transformations, the change takes place inside the function always represents a horizontal type of change. So if you do f of x plus 2, for example, it's a translation horizontal of negative 2, 0. If you have f2x, it's a horizontal stretch of factor a half. It's always like horizontal, always like opposite. It says plus, you go to the left. If it says 2 times, it's a half times. Okay, and you multiply the x coordinates by a half, and so on. So it's always like the opposite. So when it's inside the function, you got the modulus, then basically it's like a reflection in the y-axis, because that's what causes a horizontal change. But it's done in such a way that you reflect what's the positive side onto the negative side, and then what was on the negative side initially just completely disappears. So if you were to draw this, I've got something prepared here. Basically, you would reflect the positive side onto the negative side, so it looks something like this. But what was here before is completely disappears, basically. All right, so what was on the negative side is erased, and you just reflect the positive side of the negative side. That's what this looks like. So you could say that, you know, this graph has a positive argument and has a negative argument. The positive argument is when this remains as it is, okay, which is 2x squared minus 10x, okay, and so you have y equals 2x squared minus 10x. You just keep everything as it is and you don't change the sign of anything. And that would be this part of the graph, what's shown. 2x squared minus 10x. That's the positive argument of the graph. And the negative argument of the graph would be when you change the signs of what's inside. So if you change the sign of what's inside here, this becomes 2 times minus x, but you square it, minus 10 times minus x. So you end up with y equals, this becomes 2x squared and plus 10x, which happens to be this part, which is called the negative argument. So this is y equals 2x squared plus 10x. Okay, 2x squared plus 10x. So you can see here, this is the negative argument when you change the sign of the x, of what's in the modulus sign, and this is the positive argument where you leave the sign the same. Right? So this is when x is greater than 0, you have the positive argument. When x is less than 0, you have the negative argument. So this is how the sketching of this would work. We weren't asked to sketch this, but this will help us with understanding how to solve the problem. So if you want to solve the equation 2 times the modulus of x squared minus 10 times the modulus of x is equal to 48, then we take the positive argument and solve that. So we have 2x squared minus 10x equals 48. And you take the negative argument, which is 2x squared plus 10x equals 48. And we solve them and we find the solutions. So if we were to solve this equation, we can divide everything by 2. So we have x squared minus 5x equals 24. We can bring everything on one side and factorize. So x squared minus 5x minus 24 is equal to 0. So we have 2 brackets. This does factorize. I think we have 8 times 3 is 24. So it's x minus 8 and x minus 3 equals 0. So we end up with 2 solutions. X equals positive 8 and x equals, sorry, this is going to be plus 3. X equals minus 3. Okay. And for this one, again, we can, divide both sides by 2. X squared plus 5x equals 24. X squared plus 5x minus 24 equals 0. So factorizing will be almost the same, except you'll have, this time the 8 will be with the positive side and the 3 will be the negative sign. So x equals negative 8 and x equals positive 3. Now, we have to decide, are all these solutions going to be actual solutions? So what we can do here, let me just make a bit of space on this side here. So what we can do here, why is it not moving? Give me a second. Okay, that's better. Okay, is we can do a little check. So we can do an algebraic check and we can also do a graphical check. Okay, so a graphical check actually makes things very easy because basically, when you solve y equals 2x squared minus 10x equals 48, for example, then it's like you are trying to find where this curve hits this line where y equals 48. Just say this is 48 here. Okay, so this is the line y equals 48. So you can see that we have a solution here and a solution there. There's only 2 solutions for our equation which fit, but we got 4 solutions. Why did we get 4 solutions? Well, because we have this part of the graph which is not actually there. We have this part of the graph which is not actually in existence. So let me see if I can. Yeah. So you have this part. And you also have this part of the positive argument. Okay, so these are solutions which would be the 3 and the minus 3 that we got in our algebraic solution. Okay, so we got an answer over here. We got an answer over here. And those 2 answers are actually not actual answers in our graph. But we have algebraic answers which they fit. So these 2 answers are not actually real answers. The answers that we're looking for are the other 2 which are further out. So it's negative 8 and positive 8. So this would be one of the solutions and this would be the other solution. So we can see graphically that we have negative 8 and positive 8. These are the actual solutions. Okay, so we can say x equals 8 and x equals negative 8. Those are the 2 answers. We can write them together if you want as x equals plus or minus 8. Those are the solutions to this equation. That's how we solve the equation. Okay, now, if we didn't draw the graph and we wanted to check algebraically, then we'll take our original equation, which is 2 times the modulus of x squared minus 10 times the modulus of x equals 48. And we would, oops, it's got a bit funny there. And we would basically test the different values. So when x equals 8, okay, this will be 2 times the modulus of 8 squared minus 10 times the modulus of 8 on this side, and this side will be 48. That gives you 2 times 64, which is 128, minus 10 times 8, which is 80, and this side is 48, and that's the same, that's true. And if you put minus 8, the same thing would happen, because this would be minus 8, which would become basically 8 squared, which is 64, and this would be minus 8 will become positive 8. So plus or minus 8 will both end up giving you the same sum here, because the minus will become positive anyway. So both of those will give us the right answer. And if you put x equals plus 3 or minus 3, we'll end up with 2 times the modulus of 3 squared minus 10 times the modulus of 3 on this side, and this side we get 48. So here, whether you put plus 3 or minus 3, what's going to come out is 9. 2 times 9 is 18. Minus, and whether you put plus 3 or minus 3 in here, what's going to come out is positive 3. So minus 10 times 3, which is minus 30. And on this side is 48, and this is not the same. Of course, this is not the same. This is going to be negative something. So therefore, we can see that the only solutions are plus or minus 8. So you can check algebraically you can check visually to see if you get the correct answer. So there's the answer to part A of this question. And now for part B. Here it's slightly different. We have an inequality to solve where the modulus of f of x, where the whole thing is inside the modulus sign, is greater than or equal to 5 over 2x. So basically, we have to solve this inequality. So we could do this purely algebraically. We could do a mixture between algebraic and visually or graphically. Okay, so here we have to solve this. Now, here the whole thing is inside the modulus sign. Right? So in terms of transformations, if I was to draw this, okay, then what would happen to this graph is that everything above the x-axis will remain the same. First of all, this is going to be a vertical change. Why? Because it's like the whole function is affecting the whole function. It's like when you have f of x, you're adding it to the whole function plus a, or a times f of x. These are all vertical transformations and they act normalist. Plus a means you go up by a. A times f of x means you multiply by a. Here, when it's it's the whole function is affected by this modulus sign, then it's not like just the x part. Then it's going to be a vertical change. And what happens is anything below the x-axis is reflected in the x-axis and then is erased. Everything above the x-axis remains as it was. Okay, so we could, I've got something prepared a bit earlier that might help. Oops, what happened there? Okay, and this will help us to picture the situation. So basically, what happens is all of this is reflected in the x-axis and this part is erased. So it'll look something like this after the transformation. So that's how the graph of y equals the modulus of f of x. This is how it looks. Okay, it looks exactly like that. All right, so that should still be there. Just carry this. Okay, something like that. Okay, so that gives us an idea of what the graph looks like, and we've got to find when this is greater than or equal to the line y equals 5 over 2x, which is like 2.5x. Okay, so we got to see, how many times these will intersect. Okay, so we can do that by checking algebraically the solutions to this. So we have basically, we can do this in two ways. We can think about the positive, you could say the positive argument of the graph, which is going to be this part here, which will be just this unchanged. Or you can think about the negative argument of the graph, which would be this whole thing with the signs changed. Now, an easier way of doing that when you've got something like this is just to say, okay, we're going to find out where 2x squared minus 10x is equal to 5 over 2x. Where we're trying to first solve this to find where they intersect. So we'll make them equal. Right? We're basically replacing the y in here. Okay, or you can say the y in here with 2x squared minus 10x. Okay, and then we can also write 2x squared minus 10x equals minus 5 over 2x. In fact, graphically what we're doing here is we're doing minus 2x squared plus 10x equals 5 over 2x. Because this line is going to be the same no matter what. Okay, so this line will be the same. Say that's y equals 5 over 2x. All right, so it's going to be where this curve meets this line, and where that curve meets this line. We can see already they're going to meet at the origin. That's going to be one of the solutions for both of them. But we can see there's going to be probably 3 part intersections. Okay, and they will all be actually correct intersections. There won't be any of them that will be incorrect, and we can check that. So basically what we're doing is we're saying we're 2x squared minus 10x equals 5 over 2x, and we're minus 2x squared plus 10x equals 5 over 2x. But you can just do it this way, that's fine. It's the same thing, just switching the minus sign to that side. But graphically, that's what we'll be doing. So now, let me get rid of the fraction. Let me multiply by 2. So you have 4x squared minus 20x equals 5x. And this will be 2x squared minus 20x equals minus 5x. So this will give us 4x squared minus 25x equals 0. This will give us 4x squared, that should be 4 here, sorry. 4x squared minus 20x, or it gives me minus 20x plus 5x, it will be minus 15x. Let me just make that neater. That's 4x squared minus 20x minus 5x, so you get 4x squared minus 15x equals 0. Take out the common factor of x, you get 4x minus 25 equals 0. Again, 4x minus 15 equals 0. So either x equals 0 or x equals 25 over 4, and either x equals 0 or x equals 15 over 4. All right, so we have two of the solutions here. We have the solution on this side, which is, that's 15 over 4, and that's going to be 25 over 4. So we have 15 over 4 and 25 over 4, and there's 0. 3 solutions, and all of those are solutions, and then we've got to solve the inequality afterwards. So let's have a look here. Okay, so I was going to say, yeah, that's fine. So we can test these solutions if we want to in here. We can say when x equals 0, you have, this is what we're testing, modulus of 2x squared minus 10x is, I'm going to put equal to 5 over 2x. Let's see if these are actually solutions to the equation, see if those are actual points of intersection. When I put x equals 0, this is the modulus of 0, and this is 0, and that's correct. Modulus of 0 is equal to 0. When x equals 15 over 4, we have 2 times, you're going to have 15 over 4 all squared, minus 10 times 15 over 4. And on this side, you have 5 over 2 times 15 over 4. I'll just take the calculator for this. So here we have 2 times 15. Let me just put this in brackets. So 2 times 15 over 4. 2 times 15 over 4. And that's going to be squared. Minus 10 times 15 over 4. Okay, and that gives us negative 75 over 8. That's negative 75 over 8, but that's a modulus of that, so it'll end up being positive that. And here we will have the same thing. Well, let's see, 5 over 2 times 15 over 4. And that gives us 75 over 8. And this is true. This is true because the modulus of negative 75 over 8 is 75 over 8. So that gives us a true value. And we can also test it for x equals 25 over 4. Okay, so you have 2 times 25 over 4 squared minus 10 times 25 over 4. And on this side, you have 5 over 2 times 25 over 4. Let's see if we get the same. Correct. It should be all correct, I think. So we get a calculator again. And I'll just change this to 25 over 4. That gives us 125 over 8 on this side. And on this side, what do we get? We get, change this to 25. Change this to 25. Change this to 25, 1 second. And that gives us actually 125 over 8. So the modulus of 125 over 8 is equal to 125 over 8. So that's also correct. So we can see that all three of the solutions are actual solutions. Now we have to solve the inequality. And the inequality is, where is the modulus function above the y equals 5 over 2x. So I'll change the color of this to make it a bit clearer. So where is the black graph above the blue graph? And we can see it's greater than it in the areas where x is less than 0. Where x is less than 0. Okay, so we can test to see which values of, 1 second, I'll tell it to the pen. For which values of x is the modulus graph above the straight line graph. And we can see here that when x is less than 0, in this area here, if we were to draw a vertical line, for example, here, we would see that the vertical line, the values when x is equal to 0, they're equal. And when x is equal to 15 over 4, they're equal. When x equals 25 over 4, they are the same. Okay, they're exactly in the same place. Right? But when x is less than 0, the modulus graph is above the blue line. Okay, when x is less than 0. And also, actually, when x is greater than 0, it's above. So actually, when x is less than 15 over 4, the modulus graph is above. At 0, it's equal to, which still satisfies the inequality because it says less than or equal to. And when x is less than 0, it continues to be above, and it will continue to be above forever because this will carry going up, this will carry on going down. And when x is greater than 25 over 4, or when x is greater than 15 over 4, the modulus graph drops below the straight line graph. And it carries on being below it until you end up with 25 over 4 over here. And then when x is greater than 25 over 4, it starts to go above it. So we can see here that the inequality is satisfied in this region and this region when x is less than 15 over 4, less than or equal to 15 over 4, and when x is greater than or equal to 25 over 4. So it says find the set of values of x. So we can write this as when x is less than or equal to 15 over 4, or when x is greater than or equal to 25 over 4. If you want to write it in set notation, you could say that x is less than or equal to 15 over 4 union with x is greater than or equal to 25 over 4. You could write it like that if you want it in set notation, and both of those would be perfectly acceptable. So that is the answer to this question 3 from the October 2024 International A-Level Edexcel Pure Mathematics P3 paper. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of modulus functions, you can find that in the playlist over here. And in functions in general for my P3, you can find the playlist over there. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.